Welcome to this lesson on the topic of geometry. Lesson 2, Parallel Line Reasoning. In this lesson, you'll learn about parallel line relationships and how to use geometric reasoning to solve for unknown angle quantities. By the end of this lesson, you'll be able to recall that vertically opposite angles are equal in size. Recall that parallel lines are a pair of lines that never intersect. Recall that a transverse line is a line that intersects at least two other lines. Recall the definitions for alternate, corresponding, and co-interior angles. Identify alternate, corresponding, and co-interior angle relationships within situations. And finally, solve for unknown quantities using parallel line proofs. Vertically opposite. A vertically opposite relationship occurs when two lines intersect. When this occurs, four angles are made. The angles opposite one another are equal in value. This is shown in the diagram on the left. Suppose we want to know the values of x and y. We can use the vertically opposite relationship to deduce the values for both x and y. Starting with x, we simply know that the value of x is 35 degrees because if you locate x and you look at what's vertically opposite to x, you can see it's 35 degrees, so they have to match. Similarly for y, we know that y is opposite the 145 degree angle, so therefore y must also be 145 degrees in turn. We show our geometric reasoning by writing vertically opposite next to the calculations. Your turn. Draw the diagram in your book and complete the sentence. A vertically opposite relationship occurs when. Pause the video. A vertically opposite relationship occurs when two lines intersect. The opposite angles are equal in size. By now, you should be able to recall that vertically opposite angles are equal in size. Parallel lines. Parallel lines are lines that never meet. They maintain a constant distance. The parallel line relationship is represented by arrowheads on the parallel lines. A transversal line is a line that intersects two or more parallel lines. This is shown in the diagram on the left. Transversal lines cause three useful angle relationships. Bringing it back. By now, you should be able to recall that parallel lines are a pair of lines that never intersect or never touch. Furthermore, you should be able to recall that a transverse line is a line that intersects at least two other lines. Corresponding angles. A corresponding angle relationship involves matching angles across parallel and transversal lines. This is shown on the diagram. Suppose we want to solve for the values of x and y. We can use the corresponding angles relationship. Firstly, to solve for x, what you can see is that x has to be 125 degrees because of its positioning on the transversal and the parallel lines. Supposing that the parallel lines are one and the same, the x and the 125 match up. Now to solve for y, we can use our vertically opposite relationship. We know that y must be equal to x because they're vertically opposite one another. So therefore, both x and y are 125 degrees. Notice the usage of the notation of corresponding and vertically opposite. This is necessary to make sure that you're using geometric reasoning. Alternate angles. An alternate angle relationship involves matching the other angle formed by the transversal. This is shown in the diagram on the left. Suppose we want to solve for z and then x. We can first solve for z using the alternate angles relationship. Notice the positioning of the 130 degrees and the z. This is the alternate angle. So therefore we simply state z is equal to 130 degrees and state that we use the alternate relationship. After which we can solve for x. X can be solved using the supplementary relationship because x and z both form a 180 degree angle or a straight line. so therefore supplementary can be used here. Cointerior angles. A cointerior angle relationship involves the pairing of supplementary angles across two parallel lines. This is visualized in the diagram on the left. Now suppose we want to solve for first y and then z. We can first solve for y using the cointerior angles relationship. Now this one's a bit of a tricky one as it's not necessarily intuitive. What we can see is we observe the 110 degrees and the y. What we can see is that the y over here, matches in with this angle over here, and because of that what they form is sort of a supplementary relationship. So what we end up getting is the y is equal to 180 degrees minus 110. So they have to solve for 180. So therefore we discover that y is equal to 70 degrees. After which, because of the relationship between y and z, we have a corresponding relationship, or if we observe the yellow, let's say the red highlighting here, be a vertically opposite. It doesn't matter which one you use. In this case, we can simply state that z is equal to y, and I'll put it down as corresponding in this instance. And therefore we see that z is equal to 70 degrees. So overall, this has been the cointerior angles. Your turn. Categorize the parallel line relationships shown below. Remember to draw all of the diagrams into your book. Pause the video now and unpause it when you're done. Make the changes as necessary. By now, you should be able to recall the definitions for alternate, corresponding, and cointerior angles. You should be able to identify alternate, corresponding, and cointerior angle relationships within situations. And finally, you should be able to solve for unknown quantities using parallel line proofs. Your turn. Using geometric reasoning, determine the values of the unknowns in the diagram shown below. Remember to draw all diagrams in your book. Remember to use a ruler. Pause the video now and unpause as you complete each question. Part A. X is equal to 145 degrees by corresponding. B. X is equal to 41 degrees through cointerior. C. X is equal to 27 degrees. Firstly by the alternate angles relationship, and then solving for a single value of x, we divide both sides by 5. Thus, x is 27 degrees. Your turn again. D. X is equal to 70 degrees. This is first done by calculating the value of 2x using the alternate angles relationship, and then dividing both sides by 2. E. X is equal to 25 degrees. This is first done by determining the value of 2x using the cointerior relationship and then dividing by 2, after which you can discover the value of y. This is through the supplementary angles relationship. F. Using a bit of relationships here, so firstly vertically opposite, corresponding, and then supplementary, you can deduce that x is equal to 84 degrees. So again, this is done by first seeing that we have a vertically opposite relationship, then corresponding, then supplementary, and then you can take 180 degrees away because of the sum of a triangle here. In summary, in this lesson, you learnt about parallel line relationships and how to use geometric reasoning to solve unknown angle quantities. By now, you should be able to recall that vertically opposite angles are equal in size. Recall that parallel lines are a pair of lines that never intersect. Recall that a transverse line is a line that intersects at least two other lines. Recall the definitions for alternate, corresponding, and cointerior angles. Identify alternate, corresponding, and cointerior angle relationships within the situations. And finally, you should be able to solve for unknown quantities using parallel line proofs.